So up next we have 0xbrainjar, founder and CEO of Composable, who is going to talk to us about IBC-Enabled Parachains.
Hello. So obviously excited to be talking today about all the work we're doing, but I think it's also really, really important to just take a look at this slide for a second and ask ourselves, did we ever expect something like this was going to happen? Because I think in the not so distant future, Polkadot and Cosmos were very much at odds, and we're sort of bringing these two ecosystems together by bringing IBC to the Polkadot ecosystem, but also utilizing CosmWasm as a framework for XCVM. So I think the biggest problem in crypto has just generally been how can we actually build applications that make sense from the user perspective, where you have this kind of agnosticism, but also simplicity from a user experience perspective. And also I think we've now reached the point in crypto where efficiencies of the markets themselves are destined because of this kind of extreme fragmentation we've seen across all the individual markets across the DeFi space. This now invites the same sort of parallels between the equities market and the electronification there, where you saw DTCC serving a huge role in sort of merging all these markets and then resulting in more sort of user-facing applications like Robinhood, et cetera, once this efficiency had finally been manifested. And so what we've built with XCVM is a cross-chain virtual machine that serves as an orchestration layer for interoperability protocols, primarily focused on IBC, but other transport protocols can also be utilized to build aggregation protocols, retail-facing applications, and really making sure that users just have to focus on what they'd like to do as opposed to how they'd like to actually accomplish that. So when we set out to actually build retail-facing and sort of kind of mass adoption type products, we first looked at the broad interoperability stack. So initially looking at IBC, Nomad, et cetera, and quickly realized that there needed to be an orchestration layer. If you build something in the EVM context and you use something like layer 0, you're still stitching contract to contract in a very much kind of A to B to C process. There's no way for you to actually put together higher order logic for more complex applications. For instance, if you want to open up a position on a derivatives protocol, hedge it out, and also take out a loan on another chain and then invest that loan into an AMM to yield farm elsewhere, there is no sort of stack available to be able to write all these instructions in a single contract and then make sure that execution actually was happening. And so we then decided to build XCVM, which is essentially a smart contract framework on top of CosmWasm that allows for a single contract to have all this logic associated with cross-chain orchestration and be able to pass messages from chain to chain to allow for this full instruction set to be executed in a timely fashion. What this then sort of introduces is this concept of building natively cross-chain applications. So now for the first time, users and developers can interact with a framework that lets them be able to allow for this kind of high-level logic associated with interacting with multiple different chains, all from a single contract, all deployed onto a single chain. So how do we accomplish this? What is the technical stack? So I think most of you have probably already heard about what we're doing based on the work we're doing by extending IBC to other ecosystems. So for the first time, IBC is leaving the Cosmos ecosystem and going to the Polkadot ecosystem. We are the team that's spearheading that. We're also expanding IBC to near as well. And so we're sort of going all in on IBC as the desired transport layer to fuel XCVM. And then additionally, we really like WASM as a smart contracting framework for cross-chain applications. And so we've actually ported CosmWasm, taken out the sort of Tendermint-specific host functions, and have deployed them onto our Parachain, have deployed CosmWasm onto our Parachain as a palette, essentially a CosmWasm VM. So speaking a little bit more about why we decided to do some of these things, I think CosmWasm was kind of obvious. There really wasn't an alternative framework that made sense for cross-chain smart contracting for our use case. But obviously there's a whole bunch of different bridging solutions out there, but we found that IBC is essentially the most trustless solution out there, and also the most extendable solution. Where we come from in Polkadot, everyone talks about XCM, and actually XCM is not extendable to other ecosystems at this time. And so for us, choosing the most trustless solution to go all in on and push our development forward, we decided to really go all in on IBC. So why does trustless bridging even really matter? I think it's pretty straightforward. Obviously, we've seen many different bridge hacks, etc. But I think also you cannot build cross-chain applications or user-facing applications that tap into multiple chains and expect this whole thing to work if you don't have a solid foundation, aka trustless bridging. And so for us, it was super important before we could even start contemplating what is the architecture of XCVM to actually really push forth trustless bridging and build this foundation, because otherwise there's no way that an instruction set that's passing from between 6 different chains could be executed, and you'd have to rely on essentially trusted validator bridges, etc. So for us, this has been like a sort of core foundational concept with which the rest of our sort of products sort of expand out of from this central core foundation. So speaking a little bit more about expanding IBC, I think the reason why bringing IBC to other ecosystems is complicated is because of the fact that those protocols need to change in various specific ways, adding various host functions, etc. So it does require a fundamental change in the actual protocol itself, but we've taken a lot of steps with the Polkadot and Near ecosystem, speaking with the core dev teams to really push forward IBC to these ecosystems, but it's obviously difficult. And so we started this work about 9 months ago, and we're excited for Q3, Q4, where we can start to see some of these examples and actually start having DOT and Cosmos assets being able to be moved between both ecosystems. And then the Near initiatives we started, which originated a few months ago, our lead developer, Blas, is now focused on discussing how to adapt the Near protocol to make it more extendable for IBC. So this is kind of how I imagine XCVM in a sort of picture form. So obviously, Composable, just like in the Cosmos ecosystem with Cosmos SDK modules, we have palettes in the substrate context. So we've built several different palettes within our Parachain runtime to allow for execution for things like our DEX, our vaults, and of course our CosmWasm VM. And so the intention here is for XCVM to basically become this higher level orchestration stack that not only taps into this infrastructure, but also by tapping into this infrastructure is able to extend these messages and communication orchestration outside of the composable ecosystem. So from a developer perspective, this really isn't that much different than just writing a CosmWasm contract. What's nice about CosmWasm is it was built with IBC in mind. So being able to create a contract that allows you to pass messages from chain to chain, essentially this is what XCVM is. We essentially had to define the instruction set and to create a framework around a pretty already nice framework for doing cross-chain smart contracting. So to actually start this stuff up as a developer, you essentially just need to be familiar with the CosmWasm stack, familiar with IBC, and have a really solid vision as to what is the use case you actually want to accomplish. So how this actually works from a workflow perspective. So assuming you've done all the stuff I just previously mentioned, you then write a single contract with functions as general as like swap, lend, etc., which then sort of are passed to our routing layer, which specifies which protocols on which chains will these functions be directed to. Thereafter, messages are passed to satellite contracts, which contain these different instruction sets using IBC, and relayers are passing these things. So going from one satellite to the next, basically step 1, 2, 3, are all basically passed by relayers, and the intention is thereafter execution happens on multiple chains. So I think it's also very important to note that XCVM is not a rewrite of existing smart contracts and protocols. It's rather just handling state transitions, disputes, and reverts. And so we're not reinventing the wheel here. We're actually like, one of the core components within Composable is really just use what's out there. So we're using IBC. We didn't invent our own message passing protocol and use CosmWasm as a framework. We did not invent our own smart contract framework. So putting this all together, comparing this to kind of like the OSI model, we have the application layer, which is where XCVM applications would actually live, written in CosmWasm. Then you have this presentation layer, the routing layer, which again is deciding which applications and which chains to route specific functions to. And then you have the transport layer, which again, all of the stuff with XCVM, this message passing I was just speaking about, is transport protocol agnostic. So we suggest and prioritize the use of IBC, but if someone wants to use Wormhole or Nomad or something else, they can feel free to do so. And of course, everything is then foundationalized by our parachains. So what are the use cases? So I think it's, for us at Composable, we very much so started with like, what's the actual problem we want to solve? And the problem that we want to solve is, can we make crypto and DeFi in the multi-chain perspective feel as though that it is more so of a kind of back-end settlement situation and sort of parallelize it to the UXs that you see in Web 2 with respect to like equities, etc. And when we started building these infrastructure pieces, we realized that we're obviously a significant ways away from this, but I do think that with XCVM, with IBC, we will make our ways, towards actually solving this problem, and we hope to demonstrate this through a variety of these use cases that XCVM can actually power, which previously were not possible. So things like cross-chain lending, which there's obviously examples of with respect to like Aave ports, Aave v3, but you don't have, for instance, a sophisticated rebalancing logic that allows for collateral on one chain to be utilized to take out a loan in an isolated lending pair on some other chain, or maybe even some other protocol. And so this is what allows basically a single front end to be utilized for kind of one specific instruction. I want to take out a loan at less than this interest rate and not have to think about any other complexity. Another key use case as well that's really exciting from the perspective of efficiency for the market is market arbitrage. So with all these different markets in the crypto ecosystem, there's obviously massive arbitrage opportunities across yield farming, across basically AMMs. The sort of use cases there are endless. And I think for a very long time, the reason why applications have not been simple from a specifying what you want to do as opposed to how you want to do it perspective is because it's so inefficient. So our intention as well is to actually demonstrate to people, look, using XCVM, you can now more efficiently make markets across different chains. You can more efficiently route order flow across multiple different chains. And the same goes for MEV. Cross-chain MEV is a bit of a misnomer, but really the idea of passing a message from chain to chain by relayer really introduces a new revenue model for relayers as a whole, whereas previously they made no money essentially. So in this case, they'll be able to understand what action is causing a reaction and be able to react accordingly. So just doubling down a little bit on what this actually looks like from the lending perspective. So essentially as a developer, you write an XCVM contract, deploy it onto our chain, and specify collateral from this chain can be utilized as to take out a loan on another chain. And so in this example, a user can deposit an LP token. A message is then passed from one satellite contract to the other, acknowledging that this LP token collateral has been deposited, and then the loan can be taken out. And what this actually means, and kind of, I guess, why we're called composable in the first place, is we are essentially composing state transition functions across multiple different ecosystems. I want to shy away from this concept of like a cross-chain sort of like compiler situation, but essentially we're creating a framework where steps on one chain can be broadcasted to steps on another chain, which can be broadcasted to steps on a third chain. And all of this starts from a single instruction set and broadcasted all via IBC through relayers. So I think this is really powerful because for the first time now within crypto, not only will blockchains be able to talk to each other, but blockchains will actually have instructions as to why they're talking to each other in the first place. So I spoke a little bit about user experience and why we actually care about this and sort of like the original problem that Composable set out to solve. And this is a very sort of simple example of how we imagine retail-facing applications to evolve over time within the crypto ecosystem. As opposed to specifying which AMM you want to use, slippage, etc. These are all things you could select in the settings. The user doesn't need to know any of that stuff. But what the user should be able to do is specify their original assets that they have and what assets they want to end up with. And if they really care about the assets they end up with, then specifying which chain they want those assets on. For instance, in a privacy perspective, maybe you want to exit onto a privacy-preserving chain. So what this looks very similar to is just an email, right? Compose instead of swap, and that's because we're really trying to bring this concept of simplicity for the user experience. So specifying what you have in the initial state and what you want in the final state, and just composing this through a single user-facing application. I don't think there's ever been an example of an application that has been able to connect 3 different wallets and let you do something like this. And so that's obviously why we're excited about XCVM. So I think there's a huge design space as well within the UX perspective and the actual like product design perspective for cross-chain applications. A lot of times, other sort of bridging teams will focus heavily on technology, but will not really prioritize making the user feel that this is a delightful experience, but rather this is a scary experience for most people. And so for us, for something as complex in the back end as just essentially specifying what you want and what you have initially, we then have created this stepper. And the reason why we call it the sexy stepper is because it's really important for us to make the user understand where he is in the specific flow of XCVM in this instruction set, but also not to feel anxiety, right? Because if you see all of these different steps, then the user can say, okay, like this just feels too complicated, I don't want to use this stuff. And so we essentially do like indentations based to make the user feel, okay, I've now arrived onto a chain, now I'm doing something. And we provide sort of like friendly instructions, names, things like compose and spawn, things like that. So I think overall, what we're really intending to do here for Composable is putting all these pieces together: interoperability, infrastructure, tooling, XCVM, and adding all of these things up, and then investing a lot of time and energy into making the user feel that crypto is a friendly experience to actually own and use digital assets in a trustless manner. And so I think a lot of the time within this space, this sort of like C DeFi world has really popped up at the expense of decentralization, but those things really caught on because of the user experience simplicity. Things like Celsius, just deposit money, yield, that's all you need to know. These are the types of things that can be built with XCVM, but while still maintaining decentralization. So with that, I'll open the floor to questions.
Check.
Thank you for the presentation. My question is, so when you have this kind of generalized instruction set, you know, it's maybe it's like something like assembly type of thing, and you have to do kind of like a transpiling into another like smart contract or VM, I assume that there's a lot of risk for efficiency losses. Mm-hmm. So I was wondering how like you account for that. Like, you know, gas optimization is a big thing in Solidity, obviously. All the ZK stuff requires a lot of optimization for circuits. So yeah, just wondering about thoughts on that.
Yeah, that's a great question. I mean, there's a lot in there, so I'll break this down. So basically, every chain that the instruction set it moves to essentially has an interpreter. There are scenarios where essentially a message arrives and then for some reason it just will fail. Say the protocol that it wants to access now no longer exists, or the liquidity pool has no more liquidity. So that's the scenario in which we have a whole bunch of documentation about reverts, and this is also where the relayers play a very important role, because if we essentially we intend for the relayers to also play a part in like having a network for people to pay gas through relayers, so they don't have to constantly keep thinking about, okay, I need to swap my tokens to this or whatever. So I think from the reversion perspective, we will have to figure out a world in which we have honest relayers who can assist with like catching these types of things, and also having the developer actually build with failures in mind. So that's a lot of the stuff that we're doing currently at the moment. Our spec, which I'm actually tweeting out probably right after this, has a whole bunch of details about our reversion techniques. Also, error handling is like something super important to think about too. So I think the short answer is there's a lot of this stuff. Of course, like if we had a world in which ZK IBC existed, which is something I believe the Polymer team is working on in collaboration with a few other groups, this would be much more optimized, quicker. The messages would obviously, you wouldn't need a complex interpreter on every chain. But because that doesn't exist, we have this type of infrastructure at the moment. So I think the short answer is we're going to build collaborations with relayers. We're going to have to ideate and really test this out on the wild before we ship it to market. And the third piece is like we're definitely spending time looking at like the ZK scalability implications of this stuff.
Any other questions?
Yeah, you might have heard of Asta Finance and Octopus Network. I mean, I don't really know anything about them, but I heard they're also doing something similar like this. So I was just wondering, like, what is actually fundamentally different between the two approaches?
Yeah, so Octopus and Astar received a grant to build Pallet IBC. So basically to do the IBC work between, to bring IBC to Polkadot. They received this grant a year ago. We essentially just picked up their work and continued it. I'm not really sure like what they're up to at the moment. I don't really keep up with what they're doing, but essentially, like we also received a grant recently, and we sort of have been pushing a lot of this stuff forward. Not just from the Palette IBC is like one very small part of the entire bridging story for bringing IBC over. There's also IBCRS. There's also light clients on both sides. There's also working on Beefy. So these are all the different pieces that are making it take a long time for us to finish this stuff. But yeah, essentially the original work was started by Octopus and Astar.
Thank you.
Cool. Okay, thanks so much.